Okay. Well, hi. We'll wait a couple more minutes for more people to join. Just let's give it a minute. Okay, so I think we can start. So hi, nice to meet you. I'm Maria with Keymaker. I'm a solution architect for Keymaker. So what we'll do here today, we'll talk about automotive applications, AI automotive applications, and data biases in autonomous AI. Okay, so I'm sure you're more than familiar with the industry. So there are multiple automotive AI applications. So we have the main ones we want to talk about today is the in-cabin applications and the outside world. Basically, when the vehicles recognize the outside world and process the data received from the outside world, so we know how to navigate in the outside world. So there are different types of data that automotive AI is working with. So the most common one is data collected from sensors. So different sensors, LiDARs, like point clouds data, and imagery data, like videos and images. So today we'll focus on videos and images data that vehicles collect. Now, what are the most common applications for automotive AI? So I'll focus on so there are main two types, the in-cabin and the outside world. So I'll talk about first about in-cabin. So we have driver behavior recognition, distraction monitoring, emotion monitoring, attention monitoring, and different actions. We want to recognize, we want to know what's happening to the driver or what's happening to other passengers during the ride. So that's about the in-cabin main applications. Now, this data is collected as video data, mostly when we have cameras installed in the cabin, and imagery data as well. So basically, we collect those as well as sensors. Now, so what we do with this data? So basically, when we have an in-cabin AI, we want to know all kinds of different things about the passenger or the driver. So one part of this AI is to create the machine learning models, which we have whole divisions in companies dedicated to the machine learning models, to developing of the models. Or even the startups or companies that dedicated specifically to recognizing certain actions or to providing certain feedback. That's one part of it is developing. The second part, actually, what we want to talk about more today is the data creation, the training of those models. So we have the most brilliant engineers created those models. Now what we do with them, how we train those models, how we make sure that those models perform. So if those models don't perform well, if there's any issue with training data, we're talking about human life here. We're talking about a lot of responsibility that we have. So it's very, very important. It's like a biggest, I would say, the most important thing right now, theme in automotive is how we ensure that our models for in-cabin monitoring or outside world monitoring are performing perfectly and are reliable and can be trusted in the real world. So how we do it, how we train those models. So the first thing that's most important for the training of the models, of course, is to create the training data. It's the training data that goes into the models. Now, so two questions here. First, how we create this training data. And the second question is what should be the training data, how this training data should look like. So that's basically what I want to talk about today. So how this training data should look like and how we create it. Now, so going to how we create the training data. So if you focus on in-cabin monitoring, so what is done usually is a set of cameras or sensors, depends of course on the models, are set in the vehicles. So sometimes companies, if they have enough vehicles or enough equipment themselves, they'll set it up in their own machinery, either cars, buses, trucks, forklifts, or whatever vehicle we're interested in. Or the cameras are shipped or shared with other organizations. For example, at Keymaker, we sometimes have projects when we have cameras shipped to us, and we install those cameras in different vehicles and collect the data. So when we have the cameras, the sensors installed, what's important to remember? First of all, is the variety of the vehicles. So if we're talking about cars, um, so what are those vehicles? What we need to use different cars. So here's basically where the biases come in, that important to understand and to remember. So when we're choosing the cars for the project, we need to choose, let's say, different types of cars, different environments, different setups. So all this is very important to remember. So then in addition to, let's say, equipment, we need to make sure that we have different people's diversity, different people who are operating those vehicles, different size, like heights, different ethnicities, genders, age. So all that has to come into the thinking when we are planning to create the training data, when we're creating the specifications for the training data. Now, okay, so now let's say we have the vehicles, we figured out the people we want to use. What next? So there are, let's say, two main approaches to creating the training data here. So first approach is unsupervised environment, when people, let's say participants, drive or operate the vehicle, and they just do whatever they do naturally, and all this data is recorded. The second approach is specific scenarios. So basically, when we have a scenario set up, so let's say drive left, drive right, do certain gestures, look at your phone, not while driving, do certain activities. So it's all a setup scenario that operator of the vehicle should follow, and this data is recorded and used as a training, and it tries to simulate basically the real life cases and the real life scenarios. So there are pros and cons to both. So if the scenario is set up, so of course we can tell people what to do. We kind of can, in a way, navigate and guide to make sure that we cover as much various scenarios as possible. But in this case, we are missing all the unpredictable or unexpected things that can happen and we couldn't think about. Like when we drive on the road, things happen. We can never know in advance what it would be, but there are like limited amount of cases that can happen. So in this case, when we set up a scenario, we're missing the uncontrolled element of reaction and unpredictable or unexpected things, which is very important as well to include in the training data. So usually what's done is having a mix of both, some supervised environment, some unsupervised environment, having them both together kind of helps us to overcome the biases in the data. Now, additional thing that's very, very important to know when preparing those scenarios for the data creation is different locations, different conditions. So this relates a lot to autonomous driving as well. So not only for in-cabin, but for, let's say, autonomous driving capabilities. So if we're talking about self-driving cars or self-driving buses. So very interesting fact is that most of the autonomous vehicles are perfectly functionable in certain area. So for example, Tesla cars are great in California. They can self-drive in California perfectly. If you put it in Minnesota, for example, or in South America, it will not work. Why? Because the environment is so different from whatever the training data was collected and created at, which is mostly California. So how we're overcoming this? What are we doing? So basically, the most important thing to remember is to create data, collect data that comes from different environments. What is different environments? So for example, different weather conditions, snow, rain, sun, clouds, fog, which is something that happens. It's hard to simulate, but it happens, and it's very rare actually that this data, let's say extreme cases like fog or very severe rain, is used in the training data sets, but it really should. Now, additional things to remember: time of the day, the lighting, night, morning, evening, street lights on, street lights off, driving with different lighting. It's also very, very important. Now, road types, like flat road, hills, mountains, roads under construction, roads partially built. So that is something that is really confusing for machine learning models for self-driving cars specifically, all different types of the roads. So that's something to remember as well. Now, all this considerations for creating the training data for now are the main reasons we don't really have a fully autonomous driving yet, because even the most brilliant model, the most sophisticated model, if they're still missing some driving conditions, if they're still missing some scenarios from the training, they don't really know how to address them, and that can lead to very dangerous and even lethal situations when people are involved, or people can get hurt or even die. So hope we'll get there. Hope we'll get to soon when we have fully autonomous driving allowed and functioning, but not yet. So after so taking a step back, so let's say we have all this data, we collected this data, we collected videos from in-cabin, we collected videos or images from outside of the car, what we're doing with it, how we actually make this data useful for the machine learning model. So here, the most important part is working on this data, is labeling the data and enriching the data. So I want to share with you a couple examples of how it looks like. And just give me 1 second. Here we go. Can you see my screen? Okay, I hope you can see my screen. Okay, so here it's an example of a camera installed in the car, and it's a video where we have a skeleton annotation of each person, and on each frame of the video we are tracking what the person or people are doing, where they're looking, and their movements. So that's a very, very good example. Another one. So here it's also a video. Here we want to monitor the person for falling asleep. You can't really see it, but let's put it here. He's kind of falling asleep at some point. So the video here is processed where we are tracking his eyes movement, tracking his mouth, his facial features, and his movement to mark it, to label it, so the model can recognize what's happening and when. So that's an example for Incabin. So this one here, we have an example of how video from outside cameras, perception cameras can be used. So basically here we have each car, each object marked with bounding box and tracked. We have the traffic signs that are marked, and we have the lane separation where we want to learn what's happening on the road and where we can go. So that's another example. So videos like this, annotations like this are usually used for object recognition for models, like different models that are installed in vehicles that's supposed to navigate themselves in busy intersections or busy roads. For example, here we have an interesting annotation. So here it's basically a camera, a traffic light camera that's supposed to watch the road, watch the pedestrians, and watch the cars. So just to kind of explain the annotation, each object is tracked on each frame of the video. Objects that are marked with black and red lines are occluded. Blue objects are bikes. Purple objects are cars. So each object on this video is recognized and tracked. Now, why is it important? Why to do this at all? So the models themselves, if you just give them a raw video, would not be able to process it, will not be able to understand what's happening on the video. So here we're basically mapping each pixel of the video or objects of interest of the video. And we are teaching the model what is what, and we're teaching the model to recognize each object. Now, okay, so just another example. So here actually it's very interesting application of aerial AI that monitors traffic jams. So it wants to monitor the highway, it wants to monitor the bridges for traffic, and to understand if there is any traffic, if there are any congestions, and to predict what would be the best route. Okay, so that's another example. So here we have a parking monitoring from aerial point of view. The green ones are empty spaces. Everything else are cars. Red marked cars that are a bit outside of their intended border. So it's another interesting application. Okay, next one. Okay, so this is a very, very good example of data bias prevention. So here we have a video with a night scenario with lane recognition and basically sign recognition and bounding boxes around cars. So as I mentioned before, very important to include as many various scenarios, like let's say here we have night, construction, different lanes, highway, when deciding what data to use, when preparing the data. Otherwise, the models would work perfectly in a nice bright day, but will not work so well in night conditions or any other extreme or complex conditions. Okay, that's just an example, another example of aerial. Okay, so here, that's a nice example of lane annotation. So here we're basically tracking all the lanes. Okay, so that's basically another lane annotation for the bridge. Okay, what else we have here? Okay, so that's a good example of segmentation. So as I mentioned, there are different types of annotations involved. There are different techniques for preparing the training data. So the techniques I showed before. So for example, here it's basically lane marking and bounding boxes, some polygons. Now here is what we see here is semantic segmentation. So the difference between semantic segmentation and other types of annotation is that here we cover every pixel of the image or every pixel of the video. So just different type. Now, the type of annotation, the way we process the data really depends on the model. So here just like a little overview of how those annotations can look like. That's another example of semantic segmentation. Okay, that's actually another video with bounding boxes and doesn't work so well. Okay, sorry. Okay, here we have our favorite home city. So we have the line recognition with very blurry and foggy conditions. Okay. So just give me a second. Okay. So just to have a little overview of what we covered so far. So biases in data preparation, different ways to collect the data, mostly when installing the cameras, installing the sensors in the vehicles of interest, inside or outside, depends on the model. Now, quick question for you guys. Do you have any questions or anything you would like to know? You can send your questions in Q&A. Would be happy to answer. Q&A or chat, whatever works for you. Okay, so I see nobody has questions. Okay, sounds good. Yes, so for the demo, I used our annotation platform, SkiMaker's proprietary annotation platform. And now, hope I was able to say something interesting today. Please be in touch. Let me go. Okay, so if there are no questions, I think we're done for today. So thank you so much for joining us.